Greetings and welcome back. Today we'll be looking at the aldol condensation reaction, which truly is two different reactions put together. The first is the aldol reaction, followed by the condensation reaction of the aldol product. In previous lessons, we looked at how we could make a brand new carbon-carbon bond, starting with a carbonyl and an ylide, or a C- attached to a pH3+. This guy right here was my nucleophile, and this was my electrophile. In the aldol condensation, I'm going to be using a C- that is alpha to a carbonyl, and reacting that with a carbonyl as my electrophile. So therefore, I would be doing something very similar, starting with a C- and reacting it with a carbonyl, except I'm not going to have the more complicated reagents of a Wittig reaction. I'm going to do something that is more limited and yet more simple at the same time. So the classic reaction of the aldol starts with an aldehyde and reacts it with another molecule of the same aldehyde to create an aldol. So we'll start with acid aldehyde, the simplest aldehyde, and react it with another molecule of acid aldehyde. In other words, you're just putting acid aldehyde into a flask. And you add in some base, usually something like sodium hydroxide or something simple like that. These are done almost always in the presence of an O-. So let's just add sodium hydroxide or potassium hydroxide. And really, you can't attack that carbonyl, or at least it won't get anywhere. If you attack the carbonyl, the electrons would go up to the O, come back down, and kick off your OH-. So that won't get you anywhere. But OH- also acts like a base, and you'll notice that we have an alpha carbon right there. It can pull the hydrogen off of that alpha carbon, therefore giving us an enolate. And because it is an aldehyde, we would only have an enolate on one side, as there's only one alpha carbon. This is then a nucleophile, and we can attack the same molecule that has not been converted into an enolate, and that will make a new carbon-carbon bond. So note that at this point, I've used just one starting material and added a base. It's converted some molecules of the starting material into a nucleophile and left other molecules of the starting material as an electrophile, and they will react together, therefore creating a brand new carbon-carbon bond. So that CH2 would now be bound to a CHO as the electrons were kicked up to the O. The chunk over here would now be found right here. That was the electrophile. The nucleophile chunk right here is now found right there. But we have made a brand new carbon-carbon bond in between. And in the presence of water, notice that you can't just have solid potassium hydroxide, you'd have to have that in water. We would protonate the O-, giving us an aldehyde 2 doors down from an alcohol, giving us the name of this an Aldol, for aldehyde alcohol. This is also sometimes referred to as a beta hydroxy carbonyl, because right next to that carbonyl you would have an alpha, beta, and on 2 carbons down from that you have the alcohol. The reason for that is because this right here is the new bond that we just made. This reaction does work just fine with ketones, even though it's still called an aldol reaction. The ketones will do the same thing. You would want to be careful because if you had a ketone with 2 different alpha carbons, it could give you a multitude of different products. However, historically and continued to today, we still refer to this as the aldol reaction, even though it's not always an aldehyde. This, however, is not the condensation part. The condensation part occurs afterwards. I still have hydroxide hanging around, and therefore, since I still have an alpha carbon, I can use my hydroxide, well, the solution will, to pull off one of the hydrogens on that alpha carbon. That would give you that same aldol that is now converted into a C- at the alpha spot. There is a resonance in which this C- would be converted to an O-, and that would go back and forth again and a resonance structure right there. However, if this guy swings over in this direction, it can kick off that O- right there, giving us a final product that would have a C double bond C. Oops, there's still an H on there. There's still an H right there. This right here is the condensation part because we have removed water in the process. We've taken off an OH and we've taken off an H over here, and that creates water. So overall what we have is an aldol reaction to join our carbon nucleophile to our carbon electrophile. So that is the aldol reaction, followed by the condensation reaction in which you make a new double bond in between those two carbons. I'll give you another specific example. If we started with, say, acetone and added TBUOK, we could pull a hydrogen off of that alpha spot, thereby making this guy, which could react with our aldehyde, our ketone, creating a new molecule that looks like, that's my 3-carbon chunk. I would have another 3-carbon chunk and an O- there. That could get protonated, and that would form, I'll move things around a little bit, this beta hydroxycarbonyl, which would still have that alpha spot right there. And through the reaction with more base, we could create a C- right there, which would swing over and kick off our alcohol, therefore giving us the final condensation product that looks like this. Overall, what you can see is that we started off with this chunk right here and reacted it with another ketone right here. We would end up with, well, let me circle this in pink instead. The 3 carbons that were part of our nucleophile are right here, and the 3 carbons that were part of our electrophile are right here. So the alpha carbon of 1, which was our nucleophile right here, end up making part of the new double bond, and the carbonyl electrophile right there ends up as the other side, or that beta carbon 2 doors down. So what we end up making is a alpha-beta unsaturated carbonyl, and that's how the aldol reaction works. So let's try one specific example of this. So let's skip to what can happen if you use 2 different ketones or 2 different aldehydes or one of each. If you use those, what this is called is a cross or crossed aldol condensation. If you're not careful, what can happen, so let's say that if I use this ketone with this ketone, and I just add some base, well, you'll notice that I'm going to have a lot of different possibilities. That's an alpha carbon, that's an alpha carbon, that's an alpha carbon, and that's an alpha carbon. So you can end up creating 3 different nucleophiles, since these guys are right here identical, and you'll have 2 different electrophiles, so you can end up with a whole heap of different products. So when we do a cross-aldol condensation, usually what we'll do is add one molecule that has no alpha hydrogens that you can pull off, like this one. This guy has carbonyl right here, but there is no alpha carbon over here, and there is an alpha carbon right here, but it doesn't have any hydrogens. So this would have to be the electrophile. I could react that with, let's say, this molecule right here, which only has 1 alpha spot. And if I put those 2 together in the presence of base, I wouldn't have competing reactions. I would only have one side that can react like the nucleophile and one side that can react like the electrophile, and therefore I would only end up with one product. So, without going through all the details of this, and note, if you want to ask about the details, you absolutely can, we would turn this alpha, or enolizable, it can turn into an enolate, this guy into a C-, and the benzaldehyde over here would be my electrophile. So in the aldol condensation, you end up making a brand new carbon-carbon double bond between the carbon that was the nucleophile at the alpha spot and the carbon that was the electrophile right here. And therefore, the product of this would have a brand new double bond right here to that carbon that is right next to the benzene ring. So this would be an example of a crossed aldol condensation where you use two different carbonyl-containing compounds. Let's try one example of that. And thank you very much. Bring any questions you have to class.